This is Physics 30, Chapter 2, Lesson 2. This lesson is going to be all about pulleys. So, strings, pulleys, and gravity. For these examples, we're going to assume a perfect world that has no friction. If we have a 4 kilogram object sitting on top of a table or a desk or some situation, it is connected with a string via a pulley to a 10 kilogram object hanging over the edge. If we just think about this rationally, what's going to happen in this situation? Obviously, the 10 kilogram block is going to drop, pulling the 4 kilogram block along with it. So in these scenarios, we need to remember that the second of Newton's laws, that the sum of all forces will be equal to mass times acceleration. So drawing these as free body diagrams, we've got the 4 kilogram block, and the only force acting on it is the tension of the string, which we will show with a capital T. For the 10 kilogram block, there's two forces acting on it. There's the tension of the string pulling it up, and there's the force of gravity pulling it down. Now, for the force of gravity, we know that that's going to be mass times acceleration. So the mass of the object of 10 kilograms multiplied by the acceleration of gravity, which is 9.8, gives us a total downward force of 98 newtons. For the 4 kilogram block, we have the same thing, that the mass of all forces the sum of all forces will be mass times acceleration. So we know the mass of the we know the only force acting on it is the tension, so that will be equal to mass times acceleration, which we know that the mass is 4 kilograms, but we don't currently know the acceleration. So we kind of have to work back and forth between these two objects in order to find information from one of them to use with the other one. So for the 10 kilogram block, the sum of all forces, um, we know the forces acting on it are due to gravity as well as the tension of the string. So before you write down those two forces, you have to think about which direction this object is going to travel. We already know that it's going to go down due to gravity. So it means it's headed in the direction of gravity, which then means that gravity is going to be a positive force. T, on the other hand, the tension, is going to be considered as a negative force because it's working against the direction that the object is moving. So we're going to end up with this equation, where we have the force of gravity minus tension, because tension is moving in the opposite direction, is equal to the mass times acceleration. We know that the force of gravity is 98 newtons, and we know that the mass of the object is 10 kilograms. And from the previous side, with the 4 kilogram object, we have an equation for T. So we can just take that and sub that in with the 10 kilogram object as 4a. So now we can move our 4a to the other side, giving us 98 is equal to 14a, then divide both sides by 14 to give us that a would be 7 meters per second squared. Now we know with what speed the object is dropping. We know its acceleration. And since it's tied with a string to the 4 kilogram object, if that's the rate at which the 10 kilogram object is dropping, that's also going to be the same rate at which the 4 kilogram object is being pulled towards the right. So we can take that acceleration and sub it into our previous equation, giving us T is equal to 4 times 7. And so we can then find that the tension in the rope has to be 28 newtons. Another example, finding the tension in the string and the acceleration. So again, it's really important to consider the overall scenario and which direction things are going to be moving. Clearly, the 6 kilogram object is heavier, therefore it's going to drop, meaning that the 3 kilogram object is going to be moving upward. Now, because both of these objects are suspended, it means they're both going to be having the forces of tension working on them, but they're also both going to have forces of gravity working on them. So drawing a free body diagram, we get this picture with the 3 kilogram object experiencing both tension and gravity, and the 6 kilogram object also both experiencing tension and gravity. We know the force of gravity is equal to mass times acceleration, so that's going to work out to be 29.4 newtons. Same thing with the 6 kilogram object is going to work out to 58.8 newtons. Looking at the 3 kilogram object, we have the sum of all forces is mass times acceleration. So consider which way this 3 kilogram object is moving. We know it's going to be moving up, so that means anything moving in the direction that it's going is going to be considered a positive, and anything working against it will be a negative. So since the 3 kilogram object is moving up, tension is going to be the positive force, and because gravity is working against that, it's going to be considered the negative force. So we have tension minus gravity is equal to mass times acceleration. Plug in what we know. We know the gravity is 29.4 and we know the mass is 3. And then we can just shift the 29 over to give us some kind of equation for t, which we're just going to save for the time being. Then working with the 6 kilogram object, we have the same equation. The sum of all forces is mass times acceleration. With this one, because we know that the object is going to be dropping, it's moving down, we would consider gravity the positive force, because that's the force working in the direction that the object is moving, and tension the negative force, because that's moving or working in the opposite direction. So with this one, we've got gravity minus the tension is equal to mass times acceleration. Notice how this one has gravity minus tension, whereas the other one was tension minus gravity, and that's simply due to which direction the objects are moving, that this one is moving up, whereas the 6 kilogram object is moving down. So we know gravity is 58.8, and we know the mass is 6. Now, we already have an equation for t, so we can sub that whole thing in, giving us 58.8 minus all of that t is equal to 6a. We can then move over the 3a to the other side, giving us 9a, and we can combine the 58 and the 29, which then leaves us with this 29.4 equals 9a. We can divide both sides by 9, giving us that a is equal to 3.3 meters per second squared. We can then again sub that back into our equation for t and solve to get a final value that the tension will be 39.3 newtons. One last example. We have a block sliding down a ramp. So in this case, the two objects are still connected with a string and a pulley, but they're not moving vertically. Well, the 4 kilogram object is, the 3 kilogram object is sitting on a incline. So this means that it won't be, the 3 kilogram object will not be experiencing the full weight of gravity. It'll only be experiencing a portion of it. Um, it's a um, I can't think of the word. Um, it's a midpoint between the two other examples. The very first example we had sitting on the table, the object is being pulled directly right. There's no gravity being felt. The other one was being lifted straight up, so it had the full weight of gravity. This one's on an incline, so it's halfway between those two scenarios. So in that case, we need a new equation, and that is this one. Assuming there is no friction, anything on an incline, we will have that the acceleration is equal to gravity times the sine of the angle. Acceleration is gravity times sine theta. So when we put it into a free body diagram, we'll get this picture. We know the angle is 30 degrees. We've got the force of gravity pulling straight down. However, the natural force, the one that counteracts gravity, is at the same angle of the incline. So it's also at 30 degrees. So then we have a different force that we can label with Fd, which is um, the directional force, essentially. It's the portion of gravity that we will be feeling. So we know that this portion of gravity that we will be feeling is equal to the force of gravity multiplied by sine theta. That's just the equation from the previous slide. And we know that the force of gravity is mass times acceleration. So we can say mass times acceleration times sine theta. The mass is 3, acceleration of gravity is 9.8, and we know that the angle is 30 degrees. So we can multiply that all to find that Fd would be equal to 14.7 newtons. Now, we know the sum of all forces will be equal to mass times acceleration. So we have to consider what forces are working on here. Well, we've got two forces. We've got the force of tension, and we've got the Fd force. Because it's lighter than the 4 kilogram object, we know the 4 kilogram object will be dropping, which will mean that the 3 kilogram object is being pulled up the incline. So T would be our positive force, Fd is the negative force, and then we can just plug in what we know, and we get a equation for T as shown. Then turning our attention to the 4 kilogram object, we can again say mass times acceleration, which will work out to 39.2 newtons. Since this object is dropping, we will consider gravity the positive force because it's working in the same direction, and tension the negative force. So we have this, we can plug in T from our previous equation. We can solve for A, which will give us 3.5 meters per second squared. Sub that back into the equation for T, and we'll get a final result of the tension being 25.2 newtons.